So we'll start with a quick review question. I bring this up almost every class. Derivative means slope, that's a rate of change. Integral means area. Okay, so you've done the first part of this. There's two parts to the fundamental theorem. We've done the first part. An integral of a derivative, that is area under the curve. Do you remember the Riemann sums that we did with all of the rectangles, and then we did the trapezoids too, and you added them all up? And then the idea is that if you could have an infinite number of rectangles, it would be a perfect answer, and that's the true area under the curve. So it looks like this: integral a to b f prime of x dx, and this is exactly like the one on the multiple choice that we went over, except remember how it was prime prime? If you antiderivative that, it takes you back to just prime. All right, well, if you do the antiderivative of f prime, it takes you back to just f. And you do upper boundary minus lower boundary. In the notes we did on that originally, what they do is use a lowercase f and the capital F. Does anyone sort of remember that? That drives me nuts with the lowercase and the capital. It's like, wait, hold on a second. Just put a prime on that one and then you're good. But anyway, we have covered that. That is the first part. Today, we're going to do the second part, which is a derivative of an integral. Derivative is a rate. This is the rate at which the area is changing. So you've got the area changing. It's the rate at which that is changing.
Yes, it's the rate at which.
Yeah, don't think about it too hard.
Okay, good.
So there's three different ways that this can look. And there's going to be t's in here. And I know everyone's like, can I change the t's to x's? You can't, because there's also going to be x's. So there's x's and t's, and you're going to have to go with it. All right. So leave enough space to write this 3 times, because we're going to do 3 versions of this. D dx means take a derivative with respect to x. So we're going to have integral a to b f of t dt. Those are t's. I try to make the t's a little curly so that they don't look like plus signs. So real quick, if I cover this up, you would do an antiderivative. You would do upper boundary minus lower boundary, pretend they're just numbers, okay? And you would get a numeric value. Following me there?
Yeah.
What is the derivative of just a number? 0. So if both of your boundaries are just numbers, like 2 and 7, it's 0. The area is not changing because you just get a numeric value. Do you get what I'm saying? There's no change happening. All right. So next version of this, d dx, a to x, f of t dt. All you're going to do, because a derivative and an integral undo each other, right? They're inverses. So a derivative and an integral cancel out. All you're going to do is take that x and plug it into the function. So it's just f of x. Basically, the only way you can mess it up is if you do something. People take a derivative. I'm like, what are you doing? People add a plus c at the end. I'm like, what are you doing? Derivative and integral cancel out. It's just f of x. Okay. Now, real quick, because you will see this. If they reverse the boundaries, instead of f of x, it would be, what would go in front of it? If you negative, if you reverse the boundaries, it's, opposite day, you go backwards. Okay, so it'd be negative f of x if you just reverse these. So if the x is the lower boundary, because it'd be upper minus lower. So you'd have 0 minus f of x, which would just be f of x. All right, and then the last version of this is if instead of just plain x, I'm calling it g of x. And what I mean is there would be another function there. So instead of just x, it would be like 4x squared, or square root of x, or sine of x. Like it's not just x anymore, it's a function. Do you understand what I'm saying?
Yes.
Okay. What rule do we use when there's a guts inside of it? Chain rule, okay? So what you do is you take g of x and plug it in there exactly the same way we took x and plugged it in there. So it's going to be f of g of x. And then you chain on the derivative of that stuff. Which there, I wrote it at the end like a chain rule. I usually put it first so that I don't forget to do it. Okay? These are gonna be the easy, you're gonna be so happy with this lesson, okay? Like I did a lot of explaining as I'm trying to give you the foundation of why everything is what it is. But when you look at this problem, do you see derivative of an integral? Derivative and integral cancel out. All you are gonna do is take x and plug it in for t here. So the answer is x squared plus 4x minus 7. Do not take a derivative of that. Do not put a plus c. Do not put any other symbols or notation in there. That's it. Now this one, you're gonna just take x and plug it in for these t's, but good, it's flipped. So put a negative, like do that. You're gonna negate the whole thing. And then it'll be x squared minus x. I believe you could distribute the negative if you needed to. Okay? It seems pretty risky.
Yeah.
It can be if you mess up a negative, all right?
A negative.
Now, do you see how this one's not just x, how it's 5x? You would chain on the derivative of 5x. I usually just put it first though. So what's the derivative of 5x? 5, and then you would plug 5x in for t. So e to the 5x.
I like this so much.
But do you understand why it's working the way it's working? Because it's a lot of symbols to just mean that, but I want you to understand. All right, what do you think about this one? Yep, negative sine x. You just take x and plug it in, but why is it negative?
It's
On the bottom. It would be 0 minus whatever you get. So that's why it's negative.
Oh, I like
All right, how about this one?
0?
Why is that 0?
Because it's just numbers.
It's just numbers. The derivative of just a number, the derivative of a constant is 0. All right, well, this is, you got to crawl before you can walk. We're going to use this in order to do other things. All right. Now, do you see how this isn't just x?
Yes.
You have to chain on the derivative of that. I usually just do it first. Derivative of that would be 3x squared. And then you just take the x cubed and plug it in for t. Yep.
Oh, so this could be.
Wait, what happened? We flipped it over and lost our minds. Is everybody okay there?
It's gonna be a negative.
All right, yes. Why will it be a negative in front of the whole thing?
Because it's on the bottom.
It's on the lower boundary. Also, is it just x?
Nope.
No, it's x squared. So you're going to chain on the derivative of x squared, which is 2x. Again, I usually just put that first so I don't forget. And then you're going to take x squared and plug it into this. We're going to need parentheses around that. X squared squared would be x to the 4th, good, plus 5x squared. I guess if you want to distribute the negative 2x, you can do that, but that's risky. I like how you said that.
If
It's
I don't,
pretty how it is.
if I
I like that.
have to.
You could even leave it as squared squared, unless it's multiple choice. All right, what do you notice about this one? Okay, so you're gonna have to actually do upper boundary minus lower boundary. Do you guys understand? Do you guys understand why we've been able to ignore all the ones that are just numbers? Like why we didn't do anything with that 4?
That'd be 0.
And why we didn't do anything with the 7 or the 3? Good, because the derivative of just a number is 0. Here, neither of them is going to be 0, so you're going to have to actually do both of them. So first, we're going to plug in the x plus 3. So that's going to give you 2x plus 3 minus 5. That's the upper boundary. Minus, put some parentheses, and then you're going to do the lower boundary. So just plug the x in, which would be 2x minus 5. And we are actually going to work that out, but it's algebra 1. So like, give me a break. Also, it's kind of interesting what it comes out to. So I want you to see that. What would you get from this first part? 2x plus 6, good, minus 5. And then minus 2x plus 5. And so what do you notice is going to happen? Yeah, these cancel and these cancel, and you just get 6. Cool. Now here's how they tend to word things on multiple choice questions. F prime of t equals this. They give you the derivative. You want to be like, yes, they gave me the derivative. That's good. F of 6 minus f of 4. When you see that, I want your brain to go fundamental theorem of calculus. It's upper boundary minus lower boundary. Do you see that?
Yes.
So when you set up an integral, your boundaries are 4 to 6. Do you see how I did that?
Yes.
Okay. The derivative is what goes in there, which is what they gave you. 2t plus 1 dt. and then you just do the problem. Like, then you just work it out, like, just do the problem. So what's your antiderivative of 2t? T squared, good, plus antiderivative of just 1 is t, such that 4 to 6. So when you see that f of 6 minus f of 4, you want to think, oh, that's an integral, 4 to 6. It's fundamental theorem, right? So upper boundary minus lower boundary. We're going to simplify this one the whole way. You'll be all right. So 6 squared is 36. Plus 6 would be 42. Although I'm having trouble adding today, so is that right?
Yeah, that's
Okay. And then if you plug in 4, 4 squared is 16. 16 plus 4
20.
is 20, so
Nice. Yep.
22.
So why did we not make that 0? Because it's the 2 that means
So we don't have a ddx out front. We're just going to actually do the problem. Good. It's just a normal one. Okay. And this one too. They give you a whole lot of information here. We talked about this. Sometimes they just try to throw information at you to confuse you. You sort of need to like filter through all that. Here's what they want. G of 7 minus G of 2. So I want you to go, oh, fundamental theorem. It's integral 2 to 7. Good. And the derivative is what goes inside there. G prime of t dt. Now we're going to set that up and then I'll actually end up using a calculator for this one.
It's the FT in that.
Yes. Okay. Thank you. That's the next thing that I was going to say. So it's integral 2 to 7. G of t is this. So it's 5 minus t times f of t, which is what?
It's
3t squared. See, they're being as annoying about it as possible. I didn't make up this problem. I wouldn't do that. I got it from College Board. All right. But that I'm going to put in the calculator. This gives us an opportunity to remember how to type these in. Do you remember how to type an integral?
Math 9.
Yep, math 9. And if you don't remember that it's 9, look it. If you go, yeah, well, 8 is derive, it says derive, and then it says int, all right? So we're just going to type that in. Now, I know it says t, but I'm still going to type what? X. So parenthesis, 5 minus x, close parenthesis, new parenthesis, 3x squared minus 4x cubed, close parenthesis, dx. There's your answer.
That's nice.
So the takeaway is, hold on, I can't talk and write at the same time. The takeaway is when you see this, you want to think integral. Cool. G of 7 minus G of 2. It's integral 2 to 7. And what goes inside of the thing? What goes inside? The derivative. The derivative is what goes inside. Okay, cool.